Greetings of the day. I'm Dr. K. Raghuram Mohan Reddy. The course name is Unconventional Machining Process, and the topic is Chemical Milling Process Advantages and Limitations. Okay, I'm the professor of Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. So these two are the course learning outcomes. Okay, so at the end of this session, student will be able to understand the advantages of chemical milling, understand the limitations of chemical milling. These two are very much important. Why? Because we have to go with various chemical and chemical compositions for the material removal for this chemical process. So we must know the advantages and the limitations too. Okay, right. Non-traditional machining process is broadly classified into mechanical, thermal, and chemical and electrochemical. Okay. So in mechanical, ultrasonic machining, water jet machining, abrasive water jet machining, ice jet machining. In thermal, electro discharge machining, electron beam machining, laser beam machining, ion beam machining, plasma beam machining. In chemical and electrochemical, chemical milling, plasma chemical milling, electrochemical milling. Now let us discuss this chemical milling and its advantages. Okay, the chemical milling has the following advantages. Weight reduction is possible on complex contours that are difficult to machine using conventional methods. This is the first most important advantage. Okay, usually in conventional methods we cannot go with the required features and complexities, so we have to go with this chemical milling process, okay, for the complex contours, okay, for the removal or weight reduction. Second one, simultaneous material removal from all surfaces improves productivity and reduces wrapping. So here in general or conventional machining process, we have to remove the material through different sequence of operations. Okay, it may be drilling or some taper turning or turning, okay, or plane milling, okay, etc., etc. Okay, so we have to make all those things one by one. Okay, but here we can remove the material parallelly. Okay, so simultaneous material removal from all surfaces. Okay, so we need not change the position of the workpiece as like in the conventional machining process. Third one, no burrs are formed. Usually because of the uh, single point cutting tool or multi point cutting tools, the burrs will be formed even after the machining process. Okay, so sometimes in conventional methods we have to remove those burrs with different techniques, however, but here no question of burrs. Okay, so burrs are nothing but small particles which remain even after the machining process. Even the debris may stick to that one. Sometimes the material may not be removed completely because of the existing single point or multi point cutting tools. Okay, next, no stress is induced to the workpiece, which minimizes the part distortion and makes machining of delicate parts possible. Okay, so there will not be any induced stresses or hidden stresses. Okay, which imply no part distortion or make machining of delicate parts is also possible. Next, fifth one, a continuous taper on contoured sections is achievable. See, usually in contoured sections with conventional machining process, it is very difficult to maintain continuous taper. Okay, the capital cost of equipment used for machining large components is relatively low. Okay, so usually when we go with mass production, the capital cost of the equipment is also very low. Design changes can be implemented quickly. Okay, so in conventional machining, the online or even after 50% of the work, we cannot change the designs. But here we can change the designs. Okay, and can be implemented quickly. A less skilled operator is needed. Okay, so skill is not that much required here, but in conventional machining, the operator should have proper training and skill. Okay, tooling costs are minor. So here tools are just like muskets and etchants only. So its cost is very low. Okay, the good surface quality, in addition to the absence of wears, eliminates the need for finishing operations. Just we have discussed that in conventional machining process, we have to adopt some other finishing operations even after the milling, drilling, okay, or on any other machining process. But here it is not required because already we get good surface quality. Okay, no question of burrs already we have discussed. Next, multiple parts having fine details can be machined by the gang method. Okay, so here multiple parts having fine details can be machined by the gang method. Gang method means um, more features and more uh, options to machine the as per the multiple parts design. Okay, next, decorative finishes and extensive thin web areas are possible. Okay, usually for decoration purpose or some fancy purpose, we cannot get the um, good kind of finish with the conventional machines. Here it can be very much easy to maintain and when it can be applicable for the thin web areas. Next, there are low scrap rates. Okay, so it is about 3%. Okay, so here no question of wastage. Why? Because we are removing uh, the areas with the chemical action so that it will not waste the any material. Okay, so in conventional methods we have to remove even sometimes different features. Okay, we have to remove some other unwanted areas also, but in chemical milling the scrap rate is almost negligible. However, it is just 3% as per the research. Next, process parameters. Let us look at this so that with these properties we can extend our limitations. The recent solution type, concentration, properties, mixing, operating temperature, circulation. Okay, the process is also affected by the musket and its application. Right. These parameters will have direct impacts on the workpiece regarding the following, that is etch factor, etching and machining rate, production tolerance, and surface finish. To machine high quality and low cost parts using chemical milling, we must consider these things: the heat treatment, state of the workpiece, the grain size and the range of the workpiece material, the size and finish control prior to chemical milling, the direction of rolling and weld joints, and the degree of cold work. Okay, right, now let us look at these limitations of chemical milling as per the process parameters. Okay, so chemical milling does not have limitations and areas of disadvantages. Okay, only shallow cuts are practical up to 12.27 millimeters for sheets and plates, 3.83 millimeters on extrusions, and 6.39 millimeters on forgings. Okay, second one, handling and disposal of chemicals can be troublesome. Okay, and third one, hand masking, scribing, and stripping can be time consuming, repetitive, and tedious. So, however, when we are dealing the same work repeatedly, it will be tedious and sometimes time consuming. Why? Because when we deal as per our manual operations like hand masking, scribing, it will take sometimes much time based on the operator skill and performance. Next, metallurgical homogeneous surfaces are required for best results. Okay, metallurgically, the material must have homogeneous surface. Surface imperfections are reproduced in the machine parts. Deep narrow cuts are difficult to produce. Okay, why? Because the chemical may not pass through those narrow cuts because of the some other physical actions like capillarity, etc., etc. Fillet radii are fixed by the depth of cut. Okay, so that is one of the limitations. Porous castings yield uneven etched surfaces. Welded areas frequently etch at rates that differ from the base metal. 10th one, material removal from one side of residually stressed material can result in a considerable distortion. Okay, so this is the main limitation of this chemical milling. Okay, so material removal from one side of the residually stressed material can result in a considerable distortion. So, however, we can minimize the induced stresses or residual stresses, but for few materials this may happen. Okay, the absence of residual stresses on the chemically machined surfaces can produce unfavorable fatigue strength compared with the processes that induce compressive residual stresses. So already we have discussed that for some materials there would be a chance of residual stresses, but for the most of the material, because of this chemical milling process, the residual stresses will be zero. Okay, and what will happen here because of that unfavorable fatigue strength? Okay, and induce compressive residual stresses. Hydrogen pickup and intergranular attack are a problem with some materials. Okay, the straightness of the walls is subject to fillet and undercutting limitations. Okay, scribing accuracy is limited and complex designs become expensive. Okay, and steep tapers are not practical. Okay, this is the limitation of the chemical process. So these are the applications. Okay, all the common metals include aluminum, copper, zinc, steel, lead, nickel. can be chemically machined. Okay, so aluminum, copper, zinc, steel, lead, nickel can be chemically machined, and many toxic metals such as titanium, molybdenum, zirconium can be chemically machined. Okay, and non-metallic materials including glass, ceramics, some plastics can also be used with the chemical milling process. Right. Chemical milling applications range from large aluminum airplane wing parts to minute integrated circuit chips. Okay, so big aeroplane wings to small integrated chips ICs. Okay, those are very small. Okay, the practical depth of cut ranges between 2.54 to 12.27 millimeters. Okay, so he about depth of cut, by using this chemical process we can go deeper to 12.27 millimeters as per the reports. Okay, shallow cuts in large thin sheets are of the most popular application, especially for weight reduction of aerospace components. Okay, right. Multiple designs can be machined from the same sheet at the same time. Chemical milling is used to thin out walls, webs, ribs of parts that have been produced by forging, casting, or sheet metal forming, as shown in this figure. Let us look at these forged parts. Okay, so we can perform by using this chemical process. Okay, see here, formed sheets. Okay, so here the critical area is the where the abrupt change at the deeper area of the any cup shaped parts. Okay, and here look at this. This is machine surface. This is finished by chemical milling. Okay, so thinning of parts by chemical milling. Okay, so we can make materials as per the dimensional tolerances by using chemical milling. Okay, further process applications related to improve surface characteristics include the following: elimination of alpha case from titanium forgings and superplastic formed parts. Second one, elimination of the decarburized layer from low alloy steel forgings. Third one, elimination of the recast layer from parts machined by electro discharge machine. And fourth one, removal of sharp burrs from conventionally machined parts of complex shape. Excuse me. Removal of sharp burrs from conventionally machined parts of complex shapes. Removal of a thin surface from forgings and castings prior to penetration inspection below the surface. Okay, required for the detection of hidden defects. Okay, so about material removal, the material removal or etch rate depends on the chemical and metallurgical uniformity of the workpiece and the uniformity of the solution temperature. So these things over. So these are the references associated to this presentation. So let me wind up. Thank you very much.
Like, share, and subscribe. Hit the bell icon for more updates.